Hello everyone. Welcome to the first session of Polymers. I am Srinidhi Kukila. We'll be discussing about introduction, properties and applications of polymers especially in the aerospace industry. So these are the contents we are going to discuss in this session. That is introduction, different types of polymers, its synthesis and processing, mechanical behavior, characteristics, applications of plastics, polymers in aerospace industry. Polymers. Polymers play a very important role in human life. In fact, our body is made up of a lot of polymers, example, proteins, enzymes, and many more. Other natural polymers like wood, rubber, leather, and silk are serving the human mankind for many centuries now. Modern scientific tools revolutionized the processing of polymers. Thus, available synthetic polymers like plastics, rubbers, and fiber materials. As with other engineering materials, the properties of polymers are related their constituent structural elements and their arrangements. The suffix in polymer, mer, is originated from Greek word meros, which means part. The word polymer is thus coined by means to mean material consisting of many parts or many mers. Most of the polymers are basically organic compounds. However, they can be inorganic like silicon based polymers. So this session introduces to the classification of polymers, processing and synthesis of polymers, followed by mechanism of deformation and mechanical behavior of polymers. Polymers are classified in several ways by how the molecules are synthesized, by their molecular structure, and many different parts, many different types. The better way to classify polymers in according to their mechanical and thermal behavior. Industrial polymers are classified into two main classifications, plastics and elastomers. These classifications are especially based on mechanical and thermal behavior. So, under plastics, mainly based upon mechanical and thermal behavior, there are two different classifications. One is thermoplasts, second one is thermosets. Thermoplasts are the plastics which soften when heated and harden when cooled. Processes that are totally reversible and may be repeated. These materials are normally fabricated by the simultaneous application of heat and pressure. They are usually linear polymers without any cross-linking in structure. Thermoplasts like acrylics, PVC, nylons, polypropylene, polystyrene, polymethyl, methyl acrylate like plastic lenses, etc. Second one is thermoset. These are the plastics which require heat and pressure to mold them into shape. They are formed into a permanent shape and cured or set by chemical reactions such as extensive cross-linking. They cannot be remelted or reformed into any other shape but decompose upon being heated to too high temperature. Some of the examples like anamine, epoxies, vulcanized rubbers, phenolics, unsaturated polyester resins, and amino resins are thermosets. Next is elastomers. They are also known as rubbers, These are polymers which can undergo very large elongations under load at room temperature and return to their original shape when the load is released. There are number of man-made elastomers in addition to natural rubber. These consist of coil-like polymer chains. Those can reversibly stretch by applying a force. Next, processing and synthesizing the polymers, mainly uh, forming operation. Mainly, there are two different polymer formation processes. The polymer formation processes or processing of polymer is called as polymerization. First one is addition polymerization and next one is condensation polymerization. Addition polymerization, also known as chain reaction polymerization, is a process in which multifunctional monomer units are attached one at a time in chain-like fashion to form linear or 3D macromolecules. The composition of the macromolecules is an exact multiple of that of the original reactant monomer. This kind of polymerization involves three distinction stages: initiation, propagation, and termination. Next is condensation polymerization. It is also known as step growth polymerization. It involves more than one monomer species and there is usually a small molecular weight byproduct such as water which is eliminated. The repeat unit here forms from original monomers and no product has the chemical formula of mere 1 mer repeat unit. Next is mechanical behavior of polymers. As you can see in the screen, you it is the typical stress strain curve for polymers. When you compare this stress strain curve with the stress strain curve of the metals, it is quite similar. For brittle material, it is a straight line. For usual plastic material, it is ductile, and for elastomeric material, it is very ductile. That is A, B, C, as you can see in the screen. So even though this is very much similar, the applications and their mechanical properties are very high. So mechanical properties, there are same parameters that are used for metals such as modulus of elasticity, tensile, impact, fatigue strength. However, polymers in many aspects mechanically dissimilar to metals to a much greater extent than either metals or ceramics. Both thermal and mechanical properties of polymer show a marked dependence on parameter, namely temperature, strain rate, and morphology. In addition, molecular weight and temperature relative to the glass transition play an important role that are absent for other type of materials. Characteristics and typical applications of few plastic materials. So we are going to discuss some of the majorly used plastic materials. First one is thermoplastics, second one is thermosetting plastics. So under thermoplastics, first one acrylonitrile butadiene styrene, ABS. So these are having outstanding strength, toughness, resistance to heat distortion, good electrical properties, flammable, and soluble in some organic solvents. So the major application of ABS is as refrigerator lining, lawn and garden equipments, toys, highway safety devices. Next one, acrylics. These are polymethyl methacrylates. These are having outstanding light transmission and resistance to extreme weather conditions. Some of the applications are lenses, transparent aircraft enclosures, drafting equipment, outdoor signs. Next one, fluorocarbon. These are fluorocarbons are chemically inert in almost all environments, excellent electrical properties, low coefficient of friction, may be used to 260 degrees Celsius, and relatively weak and poor cold flow properties. These are having applications in anti-corrosive seals, chemical pipes and valves, bearings, anti-adhesive coatings, high temperature electronic parts. Next one, polyamides. This you know about polyamides. The most popular one is nylons. So nylons are having very good mechanical strength, abrasion resistance, toughness, low coefficient of friction, absorbs water and some other liquids. So they are used in bearings, gears, cams, bushings, handles, and jackets for wires and cables. Next one, polycarbonates. Polycarbonates are usually used in safety helmets, lenses, light globes, base for photographic films because they are having dimensionally stable material, low water absorption, transparent, very good impact resistance and ductility. Polyethylene. Polyethylene are chemically resistant and electrically insulating, tough and relatively low coefficient of friction, low strength and poor resistance to weathering. They are used in flexible bottles, toys, tumblers, battery parts, ice trays, film wrapping materials, etc. Next is polypropylene. Polypropylene are resistant to heat distortion, excellent chemical properties, and fatigue strength. They are chemically inert and relatively inexpensive, so they are usually used in sterilizable bottles, packaging films, TV cabinets, luggages, etc. So last one is polystyrene. Polystyrene have excellent electrical properties and optical clarity, good thermal and dimensional stability, and relatively inexpensive. So they are used as wall tile, battery cases, toys, indoor lighting panels, appliance housings. So these are some of the majorly used thermoplastics. Next is thermosetting plastics or thermosetting polymers or thermosets. So majorly used are epoxies, which are having excellent combination of both mechanical properties and corrosion resistant. They are dimensionally stable, good adhesion, relatively inexpensive, and good having good electrical properties. So they are used in electrical moldings, sinks, adhesives, protective coatings, used with fiberglass laminates. Next one, phenolics. Phenolics are having excellent thermal stability to over 150 degrees Celsius. They may be compounded with a large number of resins, fillers, etc. And they are very economical. They, they are used in motor housings, telephones, auto distributors, and electrical fixtures. Next, the polymers used in aerospace industry. Commercial flights would be a lot more expensive and modern warfare jets would pose less threat to the enemy without plastic materials. Since 1970s, the use of aerospace plastics has quadrupled. Interior components like overhead bins, components for navigational and propulsion function, and structural elements can all be made out of plastic materials. Military aircraft also benefit from the use of plastics. So they are very lightweight. Plastics can be generally fabricated economically. They are not prone to corrosion. Many plastics do well in very chemically harsh environment and also in harsh weather environments. Transparent plastics are more impact resistant than glass, which increases safety. So we'll discuss some of the majorly used polymeric materials or plastics in aerospace industry. First one, polyether ketone. So polyether ketone, marketed under the trademark PEEK, is a semi-crystalline organic polymer. It exhibits superior mechanical performance and thermal properties. It is also having creep resistance and low flammability. They can also withstand large doses of radiation and having excellent hydrolysis resistance and operating at a temperature of around to the range of 200 to 250 degrees Celsius. So their common application include valve seats and pump gears. Next one, thermosetting polyamide. One class of thermosetting polyamides marketed under the trademark Meldin 7001 has excellent mechanical properties and high resistance to chemicals. With higher ductility than ceramics and lower weight than metal alloys, it is a great choice for various structural applications in aerospace industry. So they are majorly included in electrical spacers and insulators for threaded nuts and other components. Polyamide amide, marketed under the trademark Torlon, has a high mechanical strength which it retains up to 300 around 300 degrees Celsius. Polyamide amide is resistant to radiation and most chemicals at room temperature. It is flame retardant and doesn't give off smoke when burning. So they are usually used as substitutes for many metal components in aerospace industry. Polychlorotrifluoroethylene is a fluorochemical plastic with an optimal blend of physical properties, mechanical properties, fire and chemical resistance, and very low moisture absorption. It also has great electrical properties and wide range of temperature applications. These properties make the material a great material for components that are used outside or in corrosive environment. Polytetrafluoroethylene, this is mainly called as PTFE or Teflon, is a fluorocarbon polymer. It is an electrical insulator, has low flammability, high tear resistance, and retains its properties in aerospace condition. Teflon makes a great material for insulating the myriads of wire and cables in an aircraft. So, in today's economy, the high cost of fuel and the push for lower ticket prices drive airlines to purchase aircraft that are as light as possible. With their lightweight and resistance to high temperatures and corrosive materials, Plastic materials are a great choice to replace components historically made of metal alloys or rubbers. In the next decades, aircraft and aerospace technologies with plastic wings and tails are foreseeable. Thank you. If you have any doubts, please comment below. Thank you all.